The midpoint of these 2 points is the center, right? Z1 plus Z2 by 2. And similarly, the distance between these two points, that is the distance between these 2 points, right? So that is the diameter, half of that will give you the radius, right? Also of the same form, argument of Z minus A by Z minus B, right? But it is not an equation, it is inequality. So less than 3 pi by 4. The next locus is of the form argument of Z minus A by Z minus B equal to pi by 2. We have already done one locus, argument of Z minus A equal to some constant angle alpha. Then it is a ray, right? But here it is not just Z minus A divided by Z minus B. Okay, this argument is a constant, pi by 2 particularly. So what is this locus? See, A and B are fixed complex numbers. Suppose A is here and B is here, fixed complex number. Where is the point Z? What is the meaning of argument of Z minus A by Z minus B? So Z minus A is the line joining Z and A. So it is this one. Similarly, Z minus B is the line joining Z and B. Now the angle between these two, so that is called the argument of Z minus A by Z minus B, right? That is the meaning of argument. So Z minus A, Z minus B. So this angle is the argument of Z minus A by Z. See, order is important, not Z minus B by Z minus A. It will be in clockwise, okay, from Z minus B to Z minus A. So Z minus A should come in the numerator, Z minus A, and Z minus B to Z minus A, right? This is anti-clockwise, right? That is a positive direction. So if you change the angle, right, that will become reverse, right? So it is important which comes first. Z minus A by Z minus B means from Z minus B to Z minus A. So that is the anti-clockwise, right? Yes. Now this angle is a constant here, pi by 2, 90 degree. That means where should be the point Z so that this angle is always 90 degrees. That is the property of circle, right? What is the property of circle? Any point on the semicircle, right? Angle subtended by the diameter. So that is always 90 degree. So if you complete the circle whose diameter has endpoints A and B, right? Any point on the circle you consider to be Z, then the angle is always 90 degrees. So that means the locus of Z here is a circle. But there is one difference here. It is not the complete circle. Why? If you take this lower part of the circle, right, the lower half, in that case this angle is not 90 degree. This is minus 90 because Z minus A is this, Z minus B to Z minus A. That means you have to take clockwise. That become negative. So Z minus B to Z minus A. So that means it become negative. So we should not take the lower half because the angle is given to be pi by 2 only. That means only the upper half of the circle. These points are also not included. A and B are not included. Okay, only the upper part of the circle. So that is the, so it is just a semicircle, right? So pi by 2, then it is semicircle. If it is plus or minus pi by 2, then we can take the upper part and also lower part. But here it is only pi by 2. We can generalize it, right? It is only a particular case we have taken pi by 2. What if this angle is not pi by 2 but some other angle, say alpha? Okay, argument of Z minus A by Z minus B equal to some angle alpha. Almost the same thing. What is that? Instead of 90 degree, so this 2 points A and B are not the end points of diameter this time, some chord, right? That's all. That means this is not exactly semicircle, it is some arc of the circle, major arc or minor arc depending upon the angle, right? If the angle is acute, then it is the major arc, right? The angle subtended the major arc, that is acute. So here, so that's all. Instead of diameter, it is just a random chord. Okay, if particularly if this angle is 90 degrees, then it is the diameter. This chord is the diameter here. That's all. This is the general form. So again, you should not take the complete circle, only one arc of the circle, because we know that this angle, if you take the lower part, the angle is different, right? That is 180 minus, and also direction is opposite. So we have to take only one arc of the circle. So this is the next locus. General cases, argument of Z minus A by Z minus B equal to some constant angle alpha, then it is a circle. Okay, if not the complete circle, at least it is a part of the circle, right? One arc of the circle. Okay, yes. Particularly if this angle alpha is pi by 2, then it is a semicircle with the endpoints of diameter A and B. Alright, so this is the next locus. Now let us do some questions based on this. Okay. This equation is of the same form, right? So argument of Z minus A divided by z minus b equals some angle, right? So pi by 3 here. Okay, so that means it is a part of a circle, right? Arc of a circle. We have to find the center of that circle and also the radius of that circle. All right, yes, let us find it. Now what are these points a and b here? So one point is 2, the other point is minus 2, right? So 2 and minus 2 are the points which are on x-axis, right? So either side of the y-axis, right? Yes, now we have to draw the circle, the arc of the circle. But the problem is, so this circle lies here, right? The upper part, positive part, or negative part of y-axis. So that is important, right? So where is the point z? Does it lie above x-axis or below x-axis? Suppose the point is above x-axis, say here. Then what is this angle? This angle is, the first one is argument of z minus z plus 2, right? Z minus 2. So z plus 2. Argument of z plus 2, z minus 2. So that means this angle is argument of z minus 2 divided by z plus 2. Okay, but what is given is different. So what is given is argument of z plus 2 divided by z minus 2. That means it is not the point above x-axis, it is below x-axis, right? So take the point below x-axis. Now you join this. Now this is from which point, which line to which line? The first line is argument of z plus 2 to z minus 2. That means that comes first. Okay, from this to that, so that comes in the numerator. Argument of z minus 2 first divided by argument of z plus 2. So z minus 2 divided by z plus 2. That means this is what is given in the question. That means our circle lies, or the arc lies, so below x-axis. So like this, and making angle pi by 3, right? That means 60 degrees. All right, so that's all. So all these are known. Now we have to find the center and the radius of the circle. Now this is very easy, because from simple geometry, the center by symmetry lies on y-axis, right? So it lies on y-axis because these two sides, no, this is minus 2, that is plus 2. Center lies on y-axis. Where exactly on y-axis? That's what we have to find, right? The negative y-axis, but what is that value, right? So you have to find the exact position. Okay, let us find it. Okay, yes, let us use the basic geometry. Okay, yes. Now the angle subtended by the chord AB, chord joining these two, right, points, is pi by 3, 60 degree. That means what is the angle subtended by the chord at the center? Angle subtended at the circumference is 60 degree. So what is the angle subtended at the center? It is twice of that. That is the property of the circle. Twice. That means it is 120, right? 2 pi by 3. So 2 pi by 3 is the angle subtended by the same chord at the center. Okay, now we again find the half of that angle only. So what is the half of that angle? So half of that angle is again 60 degree. So that means if you consider the right angle triangle, so that angle is 60 degrees. Okay, and this base is what? That is 2 units. Okay, and then you have to find this height. So that will give you the center, right? The center is the y coordinate, right? Let us find that. So let us use simple trigonometry. Okay, in that right angle triangle, what is the value of, say, tan, right? So let us find tan, say 60 degree, because that angle is 60 degree. Let us find tan of 60 degree. So tan 60 in that triangle is the opposite side. Opposite side is 2 divided by the adjacent side, which is y, right? Y coordinate. So 2 divided by y. That will give you y value, right? So tan 60 is root 3. So the required value of y is equal to 2 divided by root 3. That means our center, see, remember, this is only the length. It's only the length, but the point is below y-axis. That means a negative value, right? So that means the center is 0. X coordinate is 0, comma, the negative value of this, negative 2 by root 3. Or we can say that minus 2 by root 3 I. Alright, or 0 comma minus 2 by root 3. That's all. So that is the center of the circle, right? Yes, that's all. So that is done. Now we have to find the radius. So radius is the hypotenuse of the triangle, right? So hypotenuse can be easily found. So to find the hypotenuse, you can use Pythagoras theorem, or we can again use trigonometry, right? So you can find sine theta, right? Sine 60 degree. So what is sine 60 degree in that triangle? Opposite side, which is 2, divided by the hypotenuse, that is the radius. Okay, so that will give you our required radius. So radius equal to, so sine 60 is root 3 by 2. Okay, so that means it is 4 divided by root 3. That's all. So that is the radius. Okay, simple geometry. Once you position this circle, right, or the arc of the circle, now basic geometry or trigonometry we can use to find the center and the radius. Alright, so center lies on y-axis, negative y-axis, and the radius is this value 4 root 3. So that is the answer. So this question is also of the same form, argument of z minus a by z minus b, right? But it is not an equation, it is inequality. So less than 3 pi by 4 but greater than pi by 4. So that means it is not just an arc, it is the region between these two arcs. So first of all, you can consider that angle 3 pi by 4. Argument of z minus a by z minus b equal to 3 pi by 4. You can draw the arc. Similarly, argument of z minus a by z minus b equal to pi by 4. We can draw the arc. The region between these two arcs is what is given. The area of that region we have to find, right? So argument of z minus a by z minus b. So what is a here? So that is 3 plus 5i. Right, and b is 1 plus 5i. Okay, yes. Now the last question, it was relatively easier because the 2 points were what? 1 and minus 1, right? So sorry, 2 and minus 2. So that means one point is on the positive x-axis, the other point is negative x-axis. So the midpoint is origin. So symmetric, right? So we did it easily. But here these are random points, right? 3 plus 5i, something like that. So, but the question is to find the area only, not the center or the position, nothing to do with position. So to find the area, you can change the position of this region, right? See, wherever you move this region, the area is going to be same. You can directly also do this question, right? Without doing anything, directly we can do this question. But to make it easier, what you do is, we do shifting the origin, right? We shift the origin so it will become a relatively easier point, right? See, what is the midpoint of these 2 points? So that is 3 plus 5i and 1 plus 5i. So the midpoint is 2 plus 5i. That 2 plus 5i can be taken as origin now. Okay, so that means the midpoint will become origin. So one point will be on that side of origin, the other point on this side of the origin, just like the last question. See, these are the points given. See, 3 plus 5i is 1 point. 3 plus 5i. And similarly, 1 plus 5i. So these are the 2 points. So our circle may be like this, or the arc, depending upon the angle. Now the midpoint is, you can find the midpoint, right? 1 plus 3, 4 by 2. So that is 2 plus 5i. That is the midpoint. But in the last question, the midpoint was origin, right? 0. That point is 2, this point is minus 2. So it was easier. So what you do, take 2 plus 5i as the origin now. Or you do one thing, simply subtract 2 plus 5i from each value, right? From each value, subtract 2 plus 5i. If you don't want to use the concept of shifting the origin, we simply call it just subtraction. So if you subtract, what will you get? So this is 1, 5i gets cancelled. That means it's just 1. And this value will be minus 1. And if you subtract 2 plus 5 from here, so that is origin. That means our circle will be like this. You understand? Now it is just like the last question where the 2 points A and B are 1 and minus 1. Okay, so that's it. That means it is relatively easier. You can directly do this question, not a problem. But I prefer to do this way because it is easier to deal with numbers like 1 and minus 1 compared to these values. Okay, yes. Now this is our circle because area is going to be same. We are not doing anything related to position. We are only finding area. So position is immaterial here. So it doesn't matter where the circle is placed. Okay, that's all. Now let us draw the arc. Okay, first of all, pi by 4. So the angle is pi by 4. So what is the arc? So that is this one, right? So angle is pi by 4. So that means it is a major segment because angle is acute. So major segment. Okay, done. Now we will draw 3 pi by 4. So that is the minor segment, right? So minor arc, right? So major arc and minor arc, right? Yes. So that is 3 pi by 4 here. Now our region lies between these two regions. Okay. So this region, area of this region is what we need to find. Okay. Let us find that area. So apart from that, there is no complex number except that we place this, we draw this arc. That's it. There is no nothing much to do with complex numbers here. Simple geometry. Okay. So let us find the area of this region. What is this region? How to find the area? So let us complete this circle. Okay. Let's complete this circle. And then remove these parts. Okay, these two are symmetric. So let us take the area to be B and B. So our required area is A. A plus B plus B is a complete circle. Okay, A plus B plus B. So that is a total circle. The total circle area can be found. But what is the radius of the circle? So radius can be found. So what is the radius of the circle? Okay, so let us find. So this angle is 45 degree, right? So the angle subtended at the arc, at the circumference, that is pi by 4. That means angle subtended at the center, so that is 90 degrees. And this base, the base of this is what? So that is 1 plus 1, 2. So the base is 2. So that means the hypotenuse, that means the two sides are, we can easily find it, right? So that is 1. So that means root 2. So root 2 is the side. So it is like this. So here it is 0, here it is 1. So this is a triangle. This is 1 unit and this angle is 45 degree. That means this is root 2. So that is the radius of the circle. This is the center. Okay. So radius of the circle is root 2. Then we can find the area of the circle. See, the regions are marked as A, B and B. Okay. Because these two are same area, B and B. And then the required area is A. So that means the total area A plus B plus B, that is the total area of the circle, which is pi r square. So pi r is root 2, pi root 2 square. So that means it is 2 pi. So 2 pi is the area of the total region, but that we don't want. We want to find the B. B, we have to subtract 2B. Okay, so A plus 2B is 2 pi. But what we want is just A. So let us find B separately. How to find B? B is what? It is the segment, right? Segment. How to find the area of the segment? So that is area of the sector. Area of that sector minus area of the triangle, right angle triangle, right? So area of the sector. What is the formula for area of sector? Half r square. R square is root 2 square. Half r square theta, right? So theta here is 90 degrees, right? Pi by 2. For that sector, the angle is pi by 2 and the radius is root 2. So half r square theta. So that is the area of the sector minus area of the triangle. That triangle is right angle triangle, right? So minus half base is root 2, height also root 2. Two adjacent sides, right? So root 2, root 2. That's it. So this will give you our required answer to get cancelled. So pi by 2 minus, that is 1. So this is the area of that portion B, which is the segment. Now we have to subtract 2B. So this value we have to substitute it here. So which means our A plus 2B. Okay, so 2B, 2 pi by 2 minus 1 equals 2 pi. So that gives you our required area A. So 2 pi minus pi. So that is pi plus 2. Pi plus 2 is the required area of the region. Alright, so that's all. Simple geometry only. See, so we identify the locus. Right, so that is the part of the circle, right? That is the region between these two arcs, right? So apart from that, then there is no complex number here, simply geometry. All right, so that's all. So just using the basic geometry, we get the answer, the area of the region pi plus 2. Okay. The endpoints of the diameter of a circle are given z1 and z2. We have to find the equation of the circle. We can do it by two methods. One method is you can find the center. The midpoint of these 2 points is the center, right? z1 plus z2 by 2. And similarly, the distance between these 2 points, so that is the diameter. We can find half of this value. So that is the radius of the circle. Center and radius are known. We can write the equation of the circle. That is one method, but we will do it by another method, right? See, take any point on the circle. Okay, take any point on the circle. Now find this angle. So what is this angle? Argument of z2 minus z1 by z1 minus z2, right? So that is the argument. That angle is always 90 degrees, right? So this z satisfies the condition argument of z2 minus z divided by z1 minus z. That angle is pi by 2. If you consider the lower part also, you can take it as plus or minus pi by 2, right? So pi by 2 will give you only the upper part. So the lower part can also be written. Okay, yes. Now that's it. So argument of a complex number is 90 or minus 90. That means that complex number is purely imaginary, right? Purely imaginary complex numbers only have argument pi by 2 or minus pi by 2. So this value is purely imaginary. So for a purely imaginary complex number, the real part is 0. So what is the formula for real part? So that number plus its conjugate divided by 2. So that is 0. Okay. So this number plus its conjugate. Okay. So let me write this number. So what is that number? So I'm writing z minus z2. Okay. Anything doesn't matter. So z minus z2 divided by z minus z1. So that is this value, same value, plus its conjugate. So what is the conjugate of that? That is plus the conjugate of that minus z2 bar divided by z bar minus z1 bar. This divided by 2, but anyway 0 equal to 0. That's all. So this is the required equation of the circle whose endpoints of diameter are Z2 and Z1. That's it. Okay, but we will cross multiply and write it. We will not leave it in the denominator, because when you have the denominator, that means we are excluding the point Z1, right, or Z2. Okay, so we don't want to exclude those points, because those points are also parts of the circle, right? So if you cross multiply, so what do you get? Z minus Z2 multiplied by Z bar minus Z1 bar, plus similarly here Z minus Z1 into Z bar minus Z2 bar equal to 0. So that's all. So this is the required equation of the circle, so with the endpoints of diameter Z1 and Z2. Okay, so this we can find the center and radius, but you will not get this form. Okay, to get it in the form, conjugate form, so we have to use this idea that any point on the circle, right, the angle subtended by these 2 points, right, this diameter at that point is 90 degrees, right, pi by 2. So using that we get this form of the circle. We can call it a diameter form of a circle. I mean, you can remember this as a formula just in case it is required, but it's not required. If it is required, this endpoints of diameter are given, you can do these 2 steps to get the answer, but if you want, you can remember this as a formula also. Okay. Here we'll find the equation of the circle passing through the 3 points 0, Z1 and Z2. Okay, yes, using some simple geometry. See, these are the 3 points lying on the circle 0, Z1 and Z2. Okay, take another point, a general point on the circle Z. The condition satisfied by all these 3 points or all these 4 points. So that is the equation of the circle. Alright, yes. So what is the condition satisfied by all these points? See, join this 0 to these points Z1 and Z2. Okay, we get 2 line segments. The angle, okay, we can find the angle, say theta is the angle. Similarly, you join this Z to these points, right, Z1 and Z2. That angle is also theta, because this is the angles, these are the angles subtended by the same chord, right? The same chord subtends same angle, equal angle. So that means, so this angle theta, this angle is also theta. So what is this angle? So what is that angle? Z minus Z1 and Z minus Z2. Okay, so that is the line segment between which we have this angle theta. So that means that is the argument of Z minus Z1 divided by Z minus Z2. So that is the angle theta. The same is the angle subtended at the origin, right, 0. So that means 0 minus Z1, 0 minus Z2, or Z1 minus 0, okay, Z2 minus 0. So argument of Z1 minus 0 divided by Z2 minus 0. These 2 angles are equal because it is a circle. Okay, yes. Now that's it. So argument of this equals argument of this, or we can subtract it. Argument of this minus argument of this, then we can divide, right? Argument of A minus argument of B. So that is same as argument of A by B. So that means argument of this one, Z minus Z1 divided by Z minus Z2 divided by, so this one. So that means you can multiply the reciprocal. So Z2 divided by Z1. So the argument of this is 0. This is taken to the left hand side, that's all. So argument of something is 0. So that means it is real, right? So this complex number is real now. For real complex number, and that complex number is same as its conjugate, or imaginary part is 0. So this is equal to its conjugate. So that means Z minus Z1 divided by Z minus Z2. Okay, so this one is equal to, multiplied by Z2 divided by Z1. That is equal to its conjugate. What is its conjugate? So Z bar minus Z1 bar divided by Z bar minus Z2 bar multiplied by Z2 bar by Z1 bar, right? Conjugate of all these values. That's it. So you simply cross multiply, you will get our required equation of the circle, right? The equation of circle means what? A condition satisfied by that point Z, a general point Z. So this is the condition. So you multiply this, you will get what do you get? Z minus Z1 multiplied by, so this one, Z2, Z bar minus Z2 bar multiplied by Z2, Z1 bar, Z1 bar, Z2. So that equals, see here. So similarly, Z minus Z2 multiplied by Z bar minus Z1 bar, okay, multiplied by Z1, Z2 bar, multiplied by Z1, Z2 bar. So that's all. So this is the condition satisfied by our point Z lying on the circle. So that is the equation of the circle. You understand? So that's it. We simply use the idea of the angle subtended by a chord on the circle at any point on the circumference is same. See, now if you interchange this Z2 and Z1, we'll get the same value, right? Yes. Now we have this one way of writing it. We can also write it another way, right? Like if you take the point on the same arc, we have taken Z in the same arc as this 0, right? What if you take the other end? So the other end means these two angles are not equal, but 180, right? So 180 minus, these two are supplementary angles, right? So we can say argument of Z, argument of that one, right? The angle at the upper half. So that plus the argument of the lower half, that equal to 0, right? There are different ways of writing the equation of the circle, but this is just one of the ways, all right? Yes, so that's it. The next locus is of the form modulus of z minus a plus mod z minus b equal to a constant k, right? A and b are fixed complex numbers as usual, so z is the variable complex number. So this is the next equation of locus, right? So mod z minus a plus mod z minus b equal to k. So far we have done many locus equations, but these equations either represent a circle or a straight line, or maybe a part of a circle, a part of a straight line. But here this equation is different. See, a and b are fixed points. Z is a point satisfying some condition. What condition? Mod z minus a, that is the distance between z and a. Similarly, mod z minus b, distance between z and b, this sum is always a constant, right? The total distance is always constant. So that is the property of a curve called ellipse. If you have already done conic section, it is very simple, but even if you have not done it, so we are not going to do much about ellipse or anything here. Simply know that it is a curve called ellipse. That's all, nothing else you need to know about ellipse here. Okay, so this total distance z minus a and z minus b, this total distance is constant, so this z will lie on a curve called ellipse, so whose equation is this one, and this is the curve ellipse. So any point on this ellipse you take, that will satisfy this condition. What condition? The distance between z and a and distance between z and b, this total is always a constant, say k here. Okay, now this a and b are called the foci of the ellipse. Okay, just know these names. So a and b are foci of this ellipse for now. All right, so each one is called a focus. Okay, two foci, and k, right? K is called the length of the major axis, this total length from this end to that end. So this total length is called the length of major axis, so that is k. We don't need to know anything about ellipse now if you are not already familiar with this ellipse. So you have to know just these points. That's all. This equation is the equation of an ellipse, and also this a and b are called the foci of the ellipse, and also the length of the major axis, this total length is k. That much is enough for ellipse, right? Now, but this comes with a condition. It is not always true. This value of k, right, this value of k should always be greater than modulus of a minus b. Why is that so? So that is simple triangle property, right? See, we know that sum of two sides is greater than the third side, right? So if it is a triangle, sum of two sides, what is sum of two sides? Mod z minus a one side, mod z minus b one side, sum of these two sides, that is k. That must be greater than the third side. What is the third side? The distance between a and b. So mod a minus b. So k must be greater than mod a minus b. Only then it will represent ellipse. Otherwise, it doesn't make sense, right? First of all, so this is like a triangle. So sum of two sides must be greater than the third side. So for this point to lie on an ellipse, the condition is that mod z minus a, that means k is greater than, right? K is greater than modulus of a minus b. Then this curve represents an ellipse. Sometimes k may be equal to mod a minus b. Is it possible? K may be equal to mod a minus b. That means the total distance, mod z minus a, mod z minus b, the distance of z from a plus z from b, this total distance is equal to the distance between a and b. That means the point z lies between these 2 points, right? It is on the line segment. So in that case, what will happen? If z lies on the line segment, what will happen? Distance between z and a and distance between z and b, this total distance is same as the distance between a and b, right? So that is simple. It is not forming a triangle in that case. It's just a line segment. So if k equals mod a minus b, in that case it will not form an ellipse. It will be just a line segment, a part of a line, right? Not a complete line. It is only the portion between the 2 points a and b. It is a line segment. Okay, but what if k is less than mod a minus b? Is that even possible? That is not possible, right? So because this total distance, the total distance will never be less than the distance between these 2 points, right? So that is not possible, right? So null set, empty set, which means if k is less than mod a minus b, so it does not form any curve, or no value of z satisfies the condition, it is empty set. Okay, so this equation may represent an ellipse, or it may be simply a line segment, or it may be a null set, depending upon the value of k, right? So only these points you have to know about this particular equation of ellipse. Okay, nothing else, right? About ellipse, the Cartesian equation of ellipse in real variables, that we will do later, right, in the conic section chapter, right? So here it is simply these points that you have to know. Okay, so that's it. Let us do a question based on this. This looks like the equation of the ellipse, right? But that comes with the condition. If the condition is satisfied, it may be an equation of an ellipse, or it may be a line segment, or it may be a null set. Okay, so what is the condition? So it is of the form mod z minus a plus mod z minus b equal to k. For ellipse, the condition is that, so if this equation to represent an ellipse, the condition is that k must be greater than, right, modulus of a minus b. So k is greater than modulus of a. What is the value of a here? So that is 3 minus of b. b is 2 plus 7i. Okay, so that means, so k is greater than, so this is 1 minus 7i. So that is greater than root 50. Okay, so k must be greater than root 50. Okay, but we want the minimum integer value, right? Which integer is just greater than root 50? So that means, so k must be equal to, not equal to, the minimum value of k is integer. Okay, so that is root 50 is what, 7 point something, right? 7 point something. So that means it must be greater than that value. So 8 is the minimum, right? The smallest integer value of k that satisfies this condition, which means if k is 8 or 9 or more than that, it will be an ellipse. Less than root 50, so that is an empty set. Exactly equal to root 50, it is a line segment. Okay, so the minimum value of integer, the minimum integer value of k satisfying this condition, right, is 8. Okay, yep. Similar to ellipse, we have one more equation. So here the difference, mod z minus a minus mod z minus b, right? So that is equal to k, right? So here the difference, right, the positive difference, that is equal to k. If the difference is constant, so that will form a curve called a hyperbola, right? So this is a hyperbola, right? So that curve looks like this, where a and b are called foci, just like the ellipse, and also this k is called the length of the major axis, that length. Okay, so that's all, right? So it is called hyperbola, so that is called ellipse. So again, nothing much to know about this for now. So just know that an equation of this form is called a hyperbola. Again, it comes with a condition, right? So it will be a hyperbola only when this condition is satisfied. This time this k must be, right, this k must be less than, right, the difference between a and b, right, modulus of a minus b. So that is obvious, right, because the difference of two sides is that is less than the third side. So in the last case, we did the sum of two sides is greater than the third side. Here the difference between the two sides of a triangle is the less than the third side, which means, so this value of k must be less than mod a minus b, only then it will represent a hyperbola. What if the difference is equal to k? So if the difference is equal to k, this z will lie on that line only, but not between a and b. It is outside, right? So it is outside that line segment. It is a part of the line only, but not between a and b, unlike the last one. Here it is outside. See, suppose z is outside, so that side. So that means mod z minus b minus mod z minus a, that is the distance between z, a and b, right? Mod z minus a is this distance, mod z minus b minus mod z minus a, that equals the distance between a and b. Okay, so that means it is just on the line segment, not on the line, but not between a and b. Okay, so anyway, it is a part of a line only. Again, if this value of k is greater than our mod a minus b, in that case it is a null set, because that is not possible, right? Geometrically it is not possible. So these are the three cases, just like ellipse. So here also we have these three cases. Just remember, an equation of this type is called a hyperbola with the condition. The condition also you have to remember, right? So that's it. Again, same condition, right? For this equation to represent hyperbola, we have the condition k must be. So for this equation to represent hyperbola, so k must be less than modulus of a minus b. K must be greater than 0 also, right? So k cannot be equal to 0 or negative, right? Because modulus cannot be negative. And also if k is equal to 0, it's not a hyperbola, right? That is the mod z minus a equal to mod z minus b. Then it will be a straight line, right? Perpendicular bisector, we have already done that. So k must be positive value and also less than mod a minus b. So that's all. So that means here in this case, so k is less than modulus of a is 3 and b is 4i, right? So that means k lies between 0 and 5. So the integer values of k can be 1, 2, 3 or 4. Okay, so that's all. These are the only possible values of k, right? Integer values of k for which this equation represents a hyperbola. Okay. Next, we are going to do some questions based on different types of equations of straight lines. We are not going to introduce new concepts here. We will only use those ideas which we are already familiar with, like basics of argument, modulus, and also some basic coordinates, right? So only using this, we will find the equations of straight lines in different forms, right? So here is the first question. Here 2 points are given, z1 and z2. We have to find the equation of straight line passing through these 2 points. So we have to find the condition satisfied by a general point z on the straight line. So that condition is called equation of straight line, right? So let us take a point z, that is a general point on the straight line. Now this point lies on the line. So this point divides these 2 points in some ratio, right? So we take that ratio to be some k is to 1. Right, so k is to 1 is the ratio. Okay, now we can use section formula to find that point z. Okay, let us find using section formula. So z can be written as, right, so 1 k is to 1 is the ratio, 1 multiplied by z1, 1 multiplied by z1 plus k multiplied by z2 divided by 1 plus k. Okay, that's all. So this is the point z. Okay, now what we can do, so we can simplify this. So z can be written as, okay, so 1 divided by 1 plus k multiplied by z1 plus k divided by 1 plus k multiplied by z2. Okay, now what we do, so we take this 1 by 1 plus k as some t. Okay, so some t, right? So this is written as t. So t multiplied by z1. Then what is this then? So if this is t, what is this? So that is 1 minus t, that's all. So 1 minus t multiplied by z2. Okay, so z equal to this, right? So this is 1 minus t, because if you add these two, we'll get 1. 1 plus k divided by 1 plus k, that is 1. So t z1 plus 1 minus t z2. So that's all. So that is the any general point on the straight line. So any general point on the straight line is of this form, and that is the equation of straight line. But there is a parameter, right? So t is called the parameter. If you change the values of t, we will get different points on the straight line. If you take t equal to say 1 by 2, you may get 1 point. If you substitute t equal to 3, you get another point. So different values you get. But that point z need not be between these 2 points z1 and z2. For example, if t is negative, suppose t is negative, that means it is external division. So that means the point need not be between these 2 lines. It may be outside the line segment also. So anywhere the point z can be anywhere on the line joining z1 and z2. Okay, so that's all. So this is generally the equation of straight line passing through the points z1 and z2. Okay. This is also an equation of a straight line, but written in a different form without any parameter t. There is no t new parameter, only using the given points z1 and z2. So we have to write the equation. So here also we have 2 points z1 and z2. We have to find the equation of straight line passing through these points. Okay, yes. Now 2 points are there. So straight line, take a point z on the same straight line. Say suppose here. Okay, now see z minus z1. So that represents the same line, right? And z minus z2, that also represents the same line, right? Because so same line only. So that means argument of z minus z1, that is the argument of the line, the angle made by the line with x-axis. What is the argument of z minus z2? That is the same thing. So this is what we observe. Argument of z minus z1 is same as the argument of z minus z2, because both represent the same line only, z minus z1 or z minus z2. Okay, yes. Now we can bring it to the left hand side here. So argument of z minus z1 minus argument of this, so we can write it as the division, right? So argument of z minus z1 divided by z minus z2, so that equals 0. Okay, argument of a complex number is 0, that means that must be a real number, right? So argument is 0, so that has to be a real number. Okay, yes. So for real number, the imaginary part is 0, or that number equals its conjugate. For a real number, that number is equal to its conjugate. So that means z minus z1 divided by z minus z2 equals its conjugate, z bar minus z1 bar divided by z bar minus z2 bar. Okay, so this is the condition. Okay, let us simplify this. Okay, so this equals, yeah, so this is z multiplied by, so z minus z1. Okay, so z multiplied by z bar minus z2 bar. Okay, so minus z1 multiplied by z bar minus z2 bar. So that equals z multiplied by z bar minus z1 bar minus z2 multiplied by z bar minus z1 bar. Okay, yes. Now let us simplify this further. Some terms might get cancelled, right? Z bar, here also z bar, so that will get cancelled. So z1 z bar, z1 z2 bar. Alright, so we have to just simplify this. If you multiply this z bar, so that gets cancelled, z bar, so that gets cancelled, and z multiplied by minus z2 bar. Here also z multiplied by minus z1 bar. So if you take z out, you will get z1 bar minus z2 bar. Okay, and similarly z bar, right? So z bar, if you take out, so minus z bar, if you take out, you'll get z1. Okay, so minus, yeah, so z bar is taken out, so then we will get minus z2. Okay, plus z2 minus z2. Okay, yes. Now so that minus plus, yeah, let's simplify this. So this is z1 z2 bar, right? Plus z1 z2 bar minus z1 z2 bar. So that equals 0. Okay, right? So just a simplification. Now see, this expression is only the value of the determinant, right? So if you expand this determinant, so what is this determinant? That is z bar 1, and then z1 bar 1, and z2 bar 1. So this is written as a determinant for convenience. See, what is the determinant? Z multiplied by this cross, z1 bar minus z2 bar. That's what is written here. Z multiplied by z1 bar minus z2 bar. Similarly, minus z bar multiplied by this z1 minus z2, z1 minus z2. And similarly, 1 multiplied by, so z1 z2 bar minus z1 z2 z1 bar. Okay, so this is written as a determinant. That's all. So this equals a 0. So that's all. So this is the equation of the straight line in complex form. Okay, but the same equation only we wrote in the last question also, but there we had a parameter t. Okay, with respect to the parameter it varies, but here this is written in terms of only the given values, right? So that's all. So this is the equation of straight line passing through the 2 points z1 and z2. Okay, yep. This is the continuation of the last question only. We derived the equation of straight line passing through 2 points, right? We wrote it in determinant form, but before writing in determinant form, we got this expression, right? So z multiplied by z1 bar minus z2 bar minus z bar multiplied by z1 minus z2 plus z1 z2 bar minus z1 bar z2 equal to 0. This is the equation of straight line passing through 2 points. Okay, yes. Now is there any relation between these numbers, this and this? Is there any relation? This and this, are there any relation between these two values? Okay, now what you do, this is the conjugate of this, correct or no? This is the conjugate of this. So we can write this as some a or something. So this will become its a conjugate. Okay, yes. Now what do? You write this value as a, let a, let's take a b, right? B equals z1 minus z2. Okay, z1 minus z2. Then this becomes b conjugate, right? Z b conjugate minus z bar b plus, okay, but what is this? This is a complex number, z1 z2 bar minus its conjugate. This is the conjugate of this. Z1 z2 bar has conjugate z1 bar z2. So what is the difference between a complex number and its conjugate, that is 2i times the imaginary part. Because what is the formula for imaginary part? Z minus Z bar divided by 2i. So Z minus Z bar is 2i multiplied by imaginary part. So this is the formula we know. So the imaginary part of Z equals Z minus Z bar by 2i. If you multiply a complex number minus its conjugate is 2i multiplied by imaginary part. So that means, so this whole thing can be written as 2i multiplied by the imaginary part of Z1, Z2 bar, that's all, Z1, Z2 bar, okay. So that equals 0, okay. So that's all. So this is the form we got. Okay, now what you do, we write it in a slightly different way. You multiply the whole thing by I, we don't want this I, right? So multiply the whole thing by I. So what will you get? So, or divide by I. So if you divide by I, so if you divide by I, you will get Z. If you divide by I, that will become minus I, because 1 divided by I is minus I. So we'll get minus I B bar. Okay, if you divide this by I, 1 by I is minus I. So plus Z bar I B. Okay, and you divide by I, so it will become plus 2 imaginary part of Z1, Z2 bar equals 0. Okay, now what do you do? Now this IB is taken as a new complex number, right? A. See, just to bring it to the given form, we are doing all this, right? So IB is taken as A. So that means this will become, so Z multiplied by, what is this then? If IB is A, its conjugate, what is the conjugate of A? It is I conjugate is minus I, B conjugate is B bar. So that means Z A bar, okay, plus Z bar A plus 2 times imaginary part. Imaginary part or real part, it is always a real number, right? Imaginary part of something is a real number. So we can consider this as some real number, 2 times some real number, right? So that you can take it as some k. So k equals 0. So that's all. So this is the form given in the question. See, the equation of a straight line can be written in the form what? So a bar z plus a z bar plus k equal to 0 for a real value of k. So k is a real number. So a is some imaginary number, right? So k is a complex number. So this is the general form of equation of straight line, right? Yes. What is this a and b? We don't know, right? So we have just taken some substitution, but the equation can be written in this form for some value of a and k. That's all. So this is the equation of a straight line in complex form. Okay. Here a straight line passes through 2 points z1 and z2. The slope of this straight line is defined as this complex slope. It is not the real slope, right? Tan theta, that is the slope of the straight line. Or if 2 points are known, we have the formula y2 minus y1 by x2 minus x1. So that is different. So this is nothing to do with that. So this is defined as a complex slope, which is given by this expression z2 minus z1 by z1 bar minus z2 bar. So this is defined, right, as a complex slope of the straight line. Okay, now if 2 points are given, so this is the straight line. Now, but instead the equation of straight line is given, right? So a z bar plus a bar z plus some k equal to 0. So this is the straight line. Now we have to find the complex slope of the straight line, right? Yes. Now how to find it? Yes. Now for finding the slope of a straight line or complex slope, we have to know 2 points on the straight line. Z1 and Z2, 2 points are known. Okay, let us assume that, so this straight line contains 2 points Z1 and Z2. So these 2 points will satisfy that equation. So this is the equation of the straight line. So a z bar plus a bar z plus k equals 0. This is the straight line given. Now Z1 and Z2 lie on this straight line, right? That means they satisfy this equation. Z1 satisfies this. So that means a z1 bar plus a bar z1 plus k equals 0, because Z1 satisfies this equation. Z2 also satisfies. So a z2 bar plus a bar z2 plus k equals 0. Now what do we do? Subtract. Okay, subtract the two equations just to eliminate that k. So we'll get a z1 bar minus z2 bar. Okay, done. Plus a bar z1 minus z2. K gets cancelled, equal to 0. Now from this we can get, so there is no z2 bar, only z1. Okay, z2. Okay, so that's all. Now you take it to the other side and divide. So we will get z1 minus z2, okay, divided by z1 bar minus z2 bar. So that equals, it's taken to the other side and you divide this value, we will get minus a divided by a bar. So that's all. So this is the complex slope. So our complex slope, because this is the formula for complex slope, z1 minus z2 by z1 bar minus z2 bar. So complex slopes are denoted by w. So that equals minus a divided by a bar. So if 2 points are given, we can use this formula to find the complex slope. If the equation of line is given in this form, then we can find the slope using this formula, minus a bar divided by, a divided by a bar, right? So that is the formula for finding the complex slope of a straight line. Okay, so that's all, right? Not that you have to remember this as a formula, but it may be useful sometimes. It's not a very important concept and all, so if you remember, it may be useful sometimes, right? So the complex slope of a straight line in this form is a minus a by a bar, and similarly if 2 points are given, this can be used as a formula to find the complex slope. Okay. Two straight lines are given with slopes w1 and w2, not real slopes, complex slopes. Real slopes, the conditions are different, right? Complex slopes. See, for real slopes, if the lines are perpendicular, what is the condition? The product of slopes, right? m1, m2 equals minus 1, right? But here it may be different, right? So we don't know. So here the two slopes are given, w1 and w2 are the slopes of the two perpendicular lines. Parallel condition is very simple, right? If the two lines are parallel, obviously the slopes are equal, right? So parallel, then the slopes are equal, w1 equals w2. So that is obvious, two lines are parallel. Now perpendicular condition. See, if the two lines are perpendicular, then what is the condition? Okay, see, let us take the two perpendicular lines, take the intersection point to be z1, okay, and there is a point z2 on the first line and there is a point z3 on the second line. You take the distance to be equal, z1, z2, the distance between z1 and z2 equal to distance between z1 and z3. You can choose the point in such a way that these two distances are equal, right? You can choose any point, but I am taking the 2 points which are equidistant from that point z1. Okay, yes, done. Now let us write the slope of the first line. What is w1, slope of the first line? We have the formula z1 minus z2 divided by z1 bar minus z2 bar. So this is the slope of the first line. Now w2, so slope of the second line. So that is z1 minus z3 divided by z1 bar minus z3 bar. That is the formula for slope. Okay, yes, done. Now we have to find the relation between them. Okay, now we have to use some concept of rotation, right? Rotation. See, this is 90 degree. How to rotate by 90 degree? Just multiply by I, right? Rotate. So what is this line joining these 2 points? z1 minus z2. That is this line. If you rotate that line by 90 degrees, you will get z1 minus z3. So to get z1 minus z3, what you do? You rotate this z1 minus z2 by 90 degree. By rotation by 90 degrees, what? Just multiplying by I. That's all. Just multiply by I. That gets rotated. So this is the relation. Okay. What do we do? Just substitute it here. So this will become z1 minus z3. What is z1 minus z3? I multiplied by z1 minus z2. Okay, done. Divided by z1 minus z2 conjugate, the conjugate of this. So you take conjugate both the sides. z1 minus z3, the whole conjugate we can write. So that is I conjugate. I conjugate is minus I. And the conjugate of z1 minus z2. So that is z1 bar minus z2 bar. Okay, yes. Now this I will get cancelled here. Okay, we can cancel this I. So it is minus of, this is minus of, what is this z1 minus z2 by z1 bar minus z2 bar? So that is what we have written as a w1. Okay, that is the slope of the first line. So this is minus w1. So slope of the second line w2 equals negative of the slope of the first line. So w2 plus w1 equals 0. So this is the condition for the two lines to be perpendicular. In real slope, we have the product minus 1, right? m1, m2 equals minus 1. But complex slopes, so the sum of the two slopes equals 0 for perpendicular lines. Parallel lines equal slope, perpendicular line, the sum is 0. Okay, yes. So here the idea is different, nothing to do with the real slope m1 and m2. So this is entirely different. So w1 plus w2 is 0 for the two lines to be perpendicular. Okay. here we'll find the distance between a point and a line. So z0 is a point. Now we have to find the length of perpendicular from this point to that line, right? Yes. Now what do we do? So from this z0, you drop a perpendicular to that line. Okay, if you drop a perpendicular to the line, that meets the line at some point, say z1. Okay, z1 is the closest point. So the distance between z0 and z1 is our required distance between the point and the line. So what we need to find is the point z1 first, and then find the distance between these 2 points. So that is our required distance between the point and the line. Okay, how to find the point z1? This z1 satisfies 2 conditions. First of all, z1 lies on the line. So z1 will lie on the line. That means, so it will satisfy, this is the equation of the line. So a z bar plus a bar z plus b equals 0. Okay, this is the equation of the line. z1 lies on the line, so z1 will satisfy the equation of the line. So a z1 bar plus a bar z1 plus b equals 0. So that is one condition. There is another condition satisfied by the point z1, that is the line joining z1 and z0 is perpendicular to the given line. Okay, that means the sum of the slopes is 0, right? That's what we derived previously. So the sum of the slopes is 0. W1 plus W2 equals 0 because the lines are perpendicular. Yes, what is the slope of the given line? What is slope of the given line? That is also derived, right? So minus a divided by a bar, so that is the slope of the line. So minus a by a bar. Okay, plus the slope of the line joining z0 and z1. So that also has a formula. So that is z1 minus z0 divided by z1 bar minus z0 bar. So this sum equals 0, right? So sum of slopes is 0 if the lines are perpendicular. Okay, now we'll have to simplify this, cross multiply. So what do you get, son? So minus a z1 bar plus a z0 bar plus a bar z1 minus a bar z0 equals 0. Okay, so here we can substitute the value of this a z1 bar from this, right? So a z1 bar can be written as minus of b minus a bar z1. So that can be substituted here. So this value can be substituted from this. So we get, so that is a bar z1 plus b plus this value plus a bar z1 equals, other terms can be taken to the other side. So a bar z0 minus a z0 bar. Okay, yes. Now this is 2 times, right? A bar z1, here also a bar z1. So 2a bar z1 equals a bar z0 minus a z0 bar minus b. So this will give you our required z1. See, what we are trying to do is find the value of z1. That's all. So we try to find z1. So z1 equals, so a bar z0 minus a z0 bar minus b, the whole thing divided by 2a bar. So once we have found z1, now we have to find the distance between z0 and z1. So that is just the difference modulus. That's all. So that implies our required distance d is equal to modulus of z0 minus z1. Okay, so z0 is as it is. Now z1 we can substitute from this. Okay, so that's all. So this will give you, so modulus of z0 minus of this value, the whole value. So a bar z0 minus a z bar minus b divided by 2a bar. Okay, so let us do the simplification to get the answer, right? So this is 2a bar z0 minus a bar z0. That means 2 times this minus 1 time this. That means, so this is a bar z0. So a bar z0 plus a z0 bar plus a z0 bar plus b divided by 2 times a bar. Okay, so modulus of that. So that's also, this is the distance between the point z0 and the given line, right? So that is of the form this one, a bar z0 plus a z0 bar plus b divided by 2a bar, right? So that is the length of perpendicular from the point z0 to that line. Okay. Here 2 points are given, z1 and z2, which are the reflections, are the mirror images of each other on the line b z bar plus b bar z equals c. Alright, we have to find the value of c, right? Almost the same idea that we used in the last question. See, z1 and z2 are on the opposite side of the line, so which are equidistant from these 2 lines. So that means what? the midpoint of z1 and z2 will lie on this line. Okay, so midpoint, that midpoint is the foot of the perpendicular. So midpoint of these 2 points, z1 plus z2 by 2, that lies on the line. That is one condition. The next condition is that the line joining z1 and z2 is perpendicular to the given line. Okay, so that's all. These are the two conditions we have to use, just like the last one. See, first thing is z1 plus z2 by 2, that is a midpoint that lies on the line. Okay, so this is the midpoint which lies on the line bz bar plus b bar z equals c. Okay, because these two are reflections of each other, so equidistant. Okay, so now let us substitute that here. So that implies b multiplied by, that is z bar. Z bar means what? z1 bar plus z2 bar divided by 2 plus b bar z. So z is z1 plus z2 divided by 2. So that equals c. Okay, if you simplify this, we'll get so b z1 bar plus b z2 bar plus b bar z1 plus b bar z2 equals 2c. Okay, this is like equation number 1. Okay, we can use it later on. So one condition, the point lies on the line. Next condition is that the slopes, right, the slope of this line joining z1 and z2 and the slope of the given line, their sum is 0 because complex slopes, right? So perpendicular, use the condition for perpendicular lines. That means the sum of slopes w1 plus w2, so that equals 0. Okay, so what is the slope of the given line? Slope of the given line is, so from that line, so it is minus b divided by b bar. So that is slope of the given line, plus slope of the line joining z1 and z2. So that is z1 minus z2 divided by its conjugate z1 bar minus z2 bar. So that equals 0. Okay, so this is the condition. Now you multiply this. So what do you get? So minus b z1 bar plus b z2 bar plus b bar z1 minus b bar z2 equals 0. This is equation number 2. Now we've got two equations. Now we have to simply add, subtract, right? We have to solve the two equations. So what we can do? So if you add these two, so b z1 bar, that gets cancelled, minus b z1 bar, and similarly minus b bar z2. So here also minus b bar z2, so that also gets cancelled. Okay, so add these two equations. So 1 plus 2, so that gives you, this term gets cancelled, that term also gets cancelled. These two terms, what is this one? b z2 bar, these two terms are added. So we'll get 2 multiplied by b z2 bar plus, so b bar z2 z1. Okay, so here also 2c plus 0, so that is 2c. This gives you the value of c, which is b z2 bar plus b bar z1 divided by that's all, right? So 2 gets cancelled, so that's it. So that is the value of c, right? Simple. So just like the last question, here also we use the idea that this line is perpendicular to the given line. The line joining z1 and z2 is perpendicular to the given line, one condition, perpendicular, and also the midpoint lies on the given line. So using these two conditions, rest of the things simple solving, right? So this is the condition, c must be equal to b z2 bar plus b bar z1 for these 2 points to be reflections of each other on the line. Okay, we can also subtract the two equations, right? So instead of adding, these two equations 1 and 2, we can also subtract it. What if you subtract the two equations 1 minus 2? So if you subtract it, what do you get? b z1 bar plus b z1 bar, that will become 2 times. So 2 times b z1 bar, and this gets cancelled. b z2 bar minus b z2 bar, we are subtracting, cancel. So b bar z1, b bar z1, that also gets cancelled. So these two terms added up, right? So b bar z2, so plus b bar z2, so that equals same 2c. So that implies c here equals b z1 bar plus b bar z2. Okay, so this can also be taken as the value of c. That means we understand that this value, this expression b z2 bar plus b bar z1 is same as b z1 bar plus b bar z2. That's what we understood from this. Now whichever is given in the option, that you can choose, right? So both can be taken as the value of c. So whichever is given, so that is our answer. This question is also of the same type. See, all these questions are similar, given in different ways, but we have to essentially use the same concept here. See, so there is a circle, mod z equal to r is a circle, right, with center origin and radius r. So that we are familiar with. Now there is a point z0 on this circle. Now we have to find the equation of the tangent. Tangent is a line, right? So line which touches this circle at that point. The equation of that line we have to find. What do we have to do? Take a general point on the line. So take a point z on the line. Okay, z is a point on the line. What is the condition satisfied by this z? That condition is called the equation of that line. That's all. Because z is not a fixed point, it is a general point, any point on the line. So what do we have? What are the conditions satisfied by z? So first, z naught, right, is a point on the circle. One condition. So z0 is a point on the circle. Okay, done. Now what is the condition satisfied by z? Z minus z0, the slope of that line, right? Let us find the slope of that tangent and slope of the line joining origin to that z0. These two are perpendicular, right? See, this is the equation of the circle. So mod z equal to r. Now z0 is on this circle, so that means it will satisfy mod z0 equal to r. So that is one condition. Now slopes perpendicular. Let us use the condition for the perpendicular lines. So these two lines are perpendicular. So slopes, sum of slopes w1 plus w2 equals 0. Okay, what is the slope of the line joining z and z0? So that is, so we have the formula z minus z0 divided by z bar minus z0 bar plus slope of the line joining origin 0 and that point z0. So that is plus, so z0 minus 0 divided by z0 bar minus 0 bar, that equals 0. Alright, these two lines are perpendicular. That's all we have to simply multiply. So z multiplied by z0 bar, right? Yes, z0 bar, and then here we multiply plus z bar z0, and then we get minus of z0. Yep. So what do you get? Yeah, cross multiply. So this is minus of z0 bar, okay, minus z0 bar. So same thing. So which means we have to, you can write it as 2 times. Okay, yes. So this is z0 bar plus z bar z0 minus I think the same thing, right? So just modulus of z0 square. Okay, that is 2 times. 2 times z bar. Z bar is modulus of z square. So mod z0 square. Okay, so equals 0. Okay, done. But what is mod z0? So that we have already written. That is r. So which means this can be written as r. So z0 bar plus z bar z0. So minus 2r square equals 0. So that is the required equation of that straight line, which is a tangent to the circle at that point z0. Okay, see, so many questions we have done based on this complex slope. So it's better to remember this as a formula, right? So I will write all the formula that we have derived in the last segment, right? The equation of straight line in different forms. So these are the formula. If you remember, that will be useful for questions like this, like the complex slope of line joining 2 points, complex slope of a general equation of a straight line, equation of straight line in non-parametric form, parametric form. All this if you remember, so that will be useful for questions like this. Alright, so these are the formulae you have to remember.